Hello, I'm Kolja Haberland, Head of Customer Support at laytec. Today I'm visiting the Ferdinand Braun Institute here in Berlin, Germany. One area of specialty here at Ferdinand Braun is development and small-scale production of semiconductor structures containing of ultra-thin layers. Let's take a look now on how that works on some of their setups. In this room, an MOVPE system is used for research applications. Gallium arsenide-based laser structures are grown. Monitoring is performed using a laytec EpiRus. laytec's first in situ system, the EpiRus, made it possible to measure in situ growth rate, ternary composition, real surface temperature and doping concentration. Here you see the EpiRus installed above a research-type MOVPE reactor. It measures both the reflectance and the reflectance anisotropy of the growing layer spectroscopically. The method is so sensitive that you can actually see the monolayers grow and even identify the orientation of the atoms on the semiconductor surface. This is Dr. Martin Zoll. He's using the EpiRus. Martin, can you explain to us what we see here?
Well, Kolja, what you see here is the fingerprint of a whole growth process of a laser structure. And when we go through all these layers, you see every layer has a different spectral shape. And when we wanted to have a laser structure emitting around 690 nanometers, so when we go to the last layer here, you can see that we have exactly matched our lasering wavelengths around 690 nanometer. And from this you can see that this EpiRus sensor helps us very much to control and adjust our growth process for the desired wavelengths.
Thank you, Martin. That was very fascinating indeed. Over the years, laytec has developed a variety of different in situ monitoring systems optimized for various applications. Here we have an Extron planetary MOVPE system as used for LED production. The reactor is equipped with laytec's EpiCurve TT tool. Here both light-emitting diodes and microelectronic components like transistors are developed. EpiCurve helps to develop, optimize and maintain the process and guarantees good quality, performance and high yield. Now we can see how the reactor is prepared for the next run. Here comes Dr. Frank Bronner.
Hello, Kolja.
Hi, Frank.
In this run, we're going to load 8 wafers simultaneously. And to view the loading procedure, let's go to the other side.
Okay, good idea.
Here you see how the 3-inch sapphire substrates are loaded into the reactor. With the EpiCurve, we get individual data for each wafer, allowing us to monitor wafer uniformity and wafer-to-wafer variations in situ. Now we are starting the process. The in situ measurement will start automatically triggered by the process.
So the real interesting part is what we actually see here on the laytec computer. For example here, the reflectance curve. We see a dramatic change here, but what's happening there, Frank?
This is reflectance at 400 nanometers. Here you see change in material. This is aluminum nitride, and this changes to gallium nitride. And you see the reflectance responds immediately to the change of material. And you see, of course, the oscillations, which give us information about the growth rate. And you see that the oscillation damps out. That is because at this wavelength, the gallium nitride is already absorbing at some thickness.
And this window here, why is this particularly interesting for you?
Here we see the laser spots of the curvature measurement. These 2 spots have a certain distance, and this distance is measured and is calculated to the curvature. And the movement of these spots gives us information about the wobble of the substrate. You see some wafers behave differently than others, so here we can learn something about the individual substrates on this receptor.
Just imagine you wouldn't have any laytec in situ tools in your reactor. How would this procedure look like?
Well, for most of our growth development of epitaxial layers, we would need a much longer time. So we can actually see some things during the growth which cannot really be measured after the growth of the whole structure. For example, we see here the aluminum nitride, there's actually no change in curvature. Just here, during gallium nitride growth, the curvature changes. This layer is strained.
So I'm very happy to see that the tools help you in your daily work, and thanks for spending the time for us and explaining all this to me.
Welcome.
I hope that our brief demonstration today could provide you with some insight into real-world applications of laytec in situ metrology. Thanks for watching.